So what were the three types of functions that we saw? One is called as a 1-1 function, which is also having another name called as injective. The second one is onto function, which is also called as surjective, and the third one is bijective. You can open page number 8. Yeah. So in page number 8 only, no, it's there. 7 and 8, I think, combined. So these three functions is what we discussed. So what does a 1-1 function speak about? If you're defining a function f, so if you're defining a function f from set A to set B, in your textbook they have given it as x and y, I'll change it to A and B. What is the set A called as? It's called as the domain set, which speaks about all the input values that we give. We give giving inputs. So what is this B called as? We call it as codomain, right? The next question is, when will this, what is the range? What is range? From the codomain set, if you take all the elements which are associated with the elements in A, right? So set of all output values is what is called as codomain. Sorry, it's called as range, sorry. Right? Now, throughout this exercise, right, one thing that you need to crack is how to prove that the given functions are either 1-1, onto, or bijective. Right? As I told you, bijective is very important for you to understand the next concept. What is the next concept I told you? The next chapter's name, inverse trigonometric function. So for that, you need to know what is the inverse of a function. So which functions will have the inverses existing? Bijective, right? So bijective means it should satisfy both 1-1 and onto. So what do? We consider two elements x1, x2 that belongs to the set A, where the function is mapped from A to B. Then we consider f of x1 is equal to f of x2, right? Then what should happen? We will solve for the relation between x1 and x2. If x1 is equal to x2, what will you get? It's a 1-1 function. If x1 is not equal to x2, then it is a many to one function. Many inputs are associated with same output, right? So the next question. Yeah, for onto function, what is that we need to do? So for onto function, codomain should be equal to range, means all the elements in the codomain set should have a pre-image associated. But what are the steps to be proven? What are the steps we follow? Yeah, tell me. Very good. Step number 1 is you will write y is equal to f of x. Then what will you do? Step 2 is write x in terms of y. You do this, write x in terms of y. Then what will you do? Then you will go and look at the function. F is mapped from A to B, right? For example, if I take this question itself, we know that y is equal to 2x because f of x is equal to 2x. Then what will you write x as? X will be equal to y by 2. This is step number 2. Then what should I look at? F is mapped from n to n, right? So this is the point. I'm assuming everyone is clear from yesterday's class, but I'm repeating it one more time. Just have a look at it. So what are we supposed to do? When you write x in terms of y, the domain and the codomain will get swapped. So when you write y is equal to f of x, this is domain and this is codomain. When you write x is equal to g of y, this will become the domain and this will become the codomain, right? Now what are we supposed to do? You need to plug in these values. In the place of y, you will plug in the values from the domain set. When you plug in the value of a natural number, what is expected? When you plug in a natural number is expected back. If that fails, so if it succeeds, it's a onto function. If it fails, it's not an onto function. Okay. So are you able to understand what I'm trying to say? Right. I think we did this problem yesterday. Right. So the same question, it will change with respect to something else. What is it? The function f is 1-1. Oh, sorry, not this one. Yeah. So prove that the function f is mapped from R to R given by f of x is equal to 2x is 1-1 and onto. In the previous case, it would have been only 1-1, but it would have not been onto. Here it is y. What are the steps again? For my satisfaction, tell me y is equal to 2x, step number 1, x is equal to y by 2. Step number 2, then what are we supposed to look at? Go to the function, the definition of function, look for the domain and the codomain. Now, who's the domain? For x is equal to y by 2. The right side one, this is the domain. When you substitute this value, what is expected? A real number is expected. Show that the function map from natural number set to a natural number set given by f of 1 is equal to f of 2 is equal to 1. Let's stop with that. What is the meaning of it? What is the meaning of it? If you have to visualize it, what do I have? I have a natural number set here. I have another natural number set on the other side, right? So I have the number starting from 1, 2, 3, so on till infinity. Here also I have the number starting from 1, 2, 3, so on till infinity, right? So what is the meaning of f of 1 is equal to 1? F of 1, the number 1 from here is associated with this according to the relation f. Then what is the meaning of f of 2 is equal to 1? 2 is also related to 1. Right? Now what happens here? It's failing to be 1, 1. So it's not a 1, 1 function. That itself helps us. Right? But we should not stop it with here, because these are the absolute values. Try to understand. What do you mean by absolute values? We know what is the value of y. Means if you plot it on a graph sheet, you know what is the value of y at x is equal to 1 and x is equal to 2. Meaning, if I plot the same thing on the graph sheet, right, what I am going to get is, observe, this is 1 comma 0, this is 2 comma 0, 3, 4, keeps on going like this. When I substitute x is equal to 1, what is this function generating? When I put x is equal to 1, what is the function generating? 1. Meaning, this point is going to be, this is 0 comma 1. So this point is going to be 1 comma 1. Makes sense? What about the next point? When I put x is equal to 2, what is the value of y corresponding to it? 2, y value is 1. So what will I get here? I hope this is clear. But what is happening after 3? So what is happening after 2? F of x is equal to x minus 1. They didn't give us the absolute values. They gave the definition of function. Means they are saying you plug in the different values of x, it will change according to this relation x minus 1. Meaning, if I start substituting 3, what will I get? So I'll get 3 comma 2. If I substitute 4, what will I get? So like this, it keeps on going, but you're not supposed to join them. Listen to this carefully. You're not supposed to join them by. It is natural number to natural number. Had the question been from real number to real number, you could have joined them. You're able to understand what I'm trying to say? See, this is the reason why I told you this chapter is important for you to understand continuity and differentiability, the 5th chapter. You would have learned this last year in the name of limits and differentiation. The same thing is changed as continuity and differentiability of whom? Of a function. Unless you have a clear understanding of these, you will not be able to solve them. Is it clear? So let's try to do it in this way. Right? This is not a continuous function. Can I speak in that language also? You're able to understand what do I mean by continuous, right? They are just discrete points. Right? Now, when x greater than 0. So they are saying, prove that this is an onto function. How? What is the step number 1? Should I take this into consideration? Not necessary. Right? F of x, instead of f of x, I'll write it as y. So y is equal to, simple. What is the next step? X is equal to y plus 1. Where should my eyes go now? Look at the definition of the domain and the codomain. So f is mapped from natural number to natural number. Now this is the domain. So for every natural number you substitute in the place of y, are you getting back a natural number? Are you? Right. Starting from where? So you can substitute from 1 also. So when you substitute 1 here, what will you get? You will get 2. Right. When you substitute 2, 3. So like this, it keeps on going. So you will write it like this. For every n that belongs to the codomain set, what will you say? There exists a natural number that belongs to the domain set, which are, you're right, what is it? You call pre-image, no? Correct. Be confident. There exists a pre-image. You're right. there exists, you can either say there exists a pre-image from which set? From the natural number set that belongs to the domain. Right? Everything is the same. Are you able to understand? Tell me. Which one? F of x is equal. In that place you will substitute it again. But you need not write that always. I'll teach you while we discuss inverse. Because that is the same method to prove that the function is onto. This is the method used to find the range. There is a method used to prove the inverse also. Okay, at that point you will understand. There I'll use that f of x is equal to. Show that the function f map from R to R defined as f of x is equal to x square is neither 1, 1 nor onto. So let's break the page into two parts, right? For it to be proven as 1, 1, what are we supposed to do? Consider x1 comma x2 that belongs to whom? R. So f of x1 should be equal to, what is f of x1? Means I need to substitute x1 here. I'll get x1 square is equal to x2 square, which implies x1 is equal to, it is plus or minus x2. Hence, it's not a 1, 1 function. This I think we did it yesterday, right? What about an onto function? What about an onto function? Same logic, nothing. Y is equal to x square. So x will be equal to, actually it will be plus or minus square root of y. Right? It's plus or minus square root of y. So f is a function map from R to R. Now what should I do? Yes. Meaning, so y has this, right? In the codomain set, you have negative real numbers also. When you substitute a negative real number, you will not get a real number, you will get an imaginary number. Right? So for all negative real numbers from which set? From the, from the codomain set. There are no pre-images in the which set? Obviously, the domain set. Am I clear with this? Right? Yes. So this is how it works. But one thing you should not get confused is, don't get confused between this plus or minus y and the one which is there inside the square root. They both are different. Are you able to understand? The previous class I told you there is a graphical way of testing a 1, 1 function. What is it? I told some test. What do we do? How do you draw that straight line? Check your notes, check your notes. How do you draw it? I gave a name also to it. You remember it, Aditya? Can you tell me? Check your notes. We call it as, we call something as horizontal line test. So if you draw a line parallel to x-axis, what is it supposed to do for it to be a 1, 1 function? The line should not cut the graph at more than 1 point, right? So for that, what I'm going to do is, f of x is equal to x square is there, no? What is the shape of it? What kind of a parabola? It's an upward parabola because the coefficient of x square is positive. So this is an upward parabola. To this, if I draw a line parallel to the x-axis, it is cutting the graph at more than 1 point. Hence, it's not onto grade. It's a many to one function, right? What about onto function? This itself is telling you, see, where is the graph confined to? Listen to this carefully. See, till now we use these steps. No, there is a simpler way to tell whether this is an onto or not. Once you draw the graph, look at the place where the graph is confined to. To which quadrants is it confined to? To the first and the second quadrant. In the first and the second quadrant, concentrate on y. Concentrate on the y-axis. In the first and the second quadrant, what is the nature of y's sign? Is it positive or negative? Both are positive. Am I clear with that point? So it is positive, meaning the graph is confined only to positive real numbers. But what do we have in the codomain set? We have real numbers, means this side there is no pre-image existing at all. Had the question been R2 R plus, then it would have been an onto function. Am I clear with that? So a small change will make the same function an onto or not, depending on how you define the domain and the codomain. So that is why, as I told you, most people miss this. I want you all to concentrate on this part. Right. Shall I proceed? So are you able to understand the graphical representation for 1, 1 and onto? Yes? Shall I proceed?
Yes, sir.
I think they have given, bro. They also gave. Okay, they took some random value and wrote it. Now let's take this. So there is a function that is defined from a natural number set to a natural number set. Okay. F of x is equal to x plus 1 when if x is odd. F of x is equal to x minus 1 if x is even. Meaning, when you take the natural number set, see, listen, when I take the natural number set, the elements start with 1, 2, 3, so on till infinity. Similarly, here the elements will be confined from 1, 2, 3, so on till infinity. So when I take x, what do you mean by if x is odd? Meaning this x is coming from this set, the first set, not the second set. X comes from the first set, y comes from the second set. So if I take an odd number, right, if I take x is equal to 1, out of these two, which function should I use? So I should use f of x is equal to x plus 1, meaning I should put 1 here. What will I get? F of 1 will be equal to 2. What is the meaning of it? When you take the input to be an odd number, you are getting an even number, because odd number plus 1 is going to be an even number. Makes sense? Similarly, when I take 3, what function should I take? Same x plus 1. So what will be the value of f of 3? 4. Means 3 is mapped to 4. Right? Now what about this number 2? When I take x is equal to Tejas, what will happen? What is that I need to consider? So I need to consider x minus 1. When I put this value, when I plug in this value, f of 2 will give me a 1, meaning this 2 is mapped to 1. 4 is mapped to, sorry, okay, I can't undo, adjust it. So 4 is mapped to 3. Are you able to visualize what I'm trying to say? So if you take in this case, is it going to be a 1, 1 function? It will be, because each input is associated to unique output. Again, when you substitute 1, you will never get 2 or 3. Each input is confined only to one output. Hence, it's a 1, 1 function. It is 1, 1. Actually, they told show that. Now, what about onto? Is it? So, for onto, what I'll do is, I'll take y is equal to x plus 1. Then x will be equal to y minus 1. So, f is a function mapped from n to n. So, it clearly says in this scenario, I am not bothered about even or odd. When I substitute a natural number here, am I getting a natural number? Yes. Then what about y is equal to x minus 1? X will be equal to y plus 1. So, f is a function map from n to n. So, when I substitute a natural number here, I am getting a natural number. Hence, it's a onto function also. Is that point clear? So, tell me one thing, when you plot these two values, these two graphs, sorry, when you plot these two functions on a graph sheet, will you get a continuous function or a discontinuous function? You will get a discontinuous one, obviously, because it's mapped from n to n. So you'll get dots, right? So please make a note of this. No, actually, see, I have to correct this. But are you allowed to substitute 1 here? Why? Because x minus 1 is defined only for even numbers. So when you substitute the even number here, right, x minus 1 is going to be even. When you substitute an even number here, what are you getting actually? You're getting an odd number. So in the place of y, you will only substitute odd numbers. Oh, you're talking about this one, no? Now y minus 1, what are you supposed to substitute? You're supposed to substitute y as even. Why? Because when x is odd, you're substituting, no? What is the value of y that is getting generated? Is odd number, ma. So this odd number, if you add a 1, it's an even number. So in this place, you will keep plugging in even numbers. So the first number that you will substitute in the place of y minus 1 is 2. You will not substitute 1. So show that an onto function. They have already told that this function is onto. Show that this onto function is also 1, 1. So how will you do this? Very simple. I have a set A, the set A, the set B. You can define it in whatever way you want. This is 1, 2, 3. This is 1, 2, 3. So for the function defined from A to B to be 1, 1, what should happen? Each element, every element from set A should be associated to a unique element in set B. When that is happening, for instance, if I take 1 is mapped to 1, then 2 is mapped to 2 and 3 is mapped to 3. Meaning, if 1 is mapped to 1, since they have already told, okay, sorry, I'm sorry. This is what is supposed to happen. But what is that they already told? They told it is an onto function. So if it has to be an onto function, what should happen? Every element in the codomain should have a pre-image. For example, had I taken it like this, then what will happen? It won't be an onto function, but they already mentioned it's an onto function. Right? So for this function to be onto, one thing that you're able to observe, I want you to observe a pattern here. What is it? What is the important thing you're able to observe from this? No, f of x1, that is something I drew. That's not given in the question. I told 1 is mapped to 1. Maybe 1 is mapped to 2 also. Can you slightly correct it? No, she's right actually. It is rare. The codame idhila solriya. Okay, idhila illa. Okay. Now I have proved that 3 is mapped to 3. This is what is supposed to happen. Means all the elements here are exhausted. They have a pre-image. You're almost there. Just add up its number of elements. That's it. So you're right actually. You're trying to say codomain is equal to domain because the numbers are same. But if you look at the number of elements, the number of elements in the domain set and the number of elements in the codomain set are equal. And if it is 1 to 1, it will always be onto also. Means it will always be bijective. That's a very, very, very important point to be noted. If the number of elements in set A is equal to the number of elements in set B, if they say it is onto, then by default it is supposed to be 1, 1 also. If this is told, see, maybe they can ask you in an assertion reason. If onto function is given, then 1, 1 by default is accepted. Yes. Same set, but the question is reverse 1, 2, 3, and you have 1, 2, 3. This is set A, this is set B. Am I right? So what are they saying? The function is meaning each element is associated with a unique output. See, for example, if I randomly draw it like that, right, then what is it happening? Each element is associated with a unique element because they have already told it is 1, 1. But what is the other thing that is getting satisfied? Codomain is equal to range. So that is one way of answering, or how will you write it? See, in this chapter, no, understanding the concept is okay. But how will you present it in the exam? How will you write it? You can either say codomain is equal to range, or the other way is n of A is equal to n of B is our logic. That is something we are remembering here. Every element in the codomain set is having a pre-image associated. That's a common language, you can use it everywhere. Are you able to understand? Yes.